Alright, so I think I'm recording. They're asking us here if we have a function that is even, odd, or neither, and I'm going to use function notation. Instead of y, I'm going to use f of x and 3x cubed minus 6x. Now, what does this function do to the input? No matter what the input is here on the left between the parentheses. This function creates a subtraction problem. Now the first number, it takes the input, no matter what it is, and it raises it to the third power. It cubes it, and then it multiplies it by 3. It subtracts 6 times that input. When I'm trying to determine whether a function is even, odd, or neither, my input is the opposite of x. So I want to input negative x here. Everywhere I see input, I'm going to replace it with negative x. I've got 3 negative x cubed minus 6 negative x. I need to simplify this and compare this expression against the original expression. I have a negative number raised to an odd exponent, and a negative base raised to an odd exponent is always going to be negative. So I've got negative 3x to the third power. Here I have a negative times a negative, which is positive. When I compare this expression against the original, I see they're not equal. The first term here is negative, the first term there is positive. So since this evaluated at negative x is not equal to the original function, I know this is not an even function. If you graph it, there is not symmetry with respect to the y-axis. Now, what about, could it be an odd function? So let's take the opposite of this answer that I got here, f evaluated at negative x. Take the opposite of f evaluated. So I take the opposite of every term. This negative becomes a positive, and this positive becomes a negative. I compare this expression against the original, and it's the same. So the opposite of f evaluated at negative x was equal to the original expression. That means that this original expression is an odd function, and it has symmetry with respect to the origin when you go to graph it. All right, so let's keep going since that was part A. Let's take a look at part B. So again, we want to continue in the same fashion. What does this function do to the input? This function takes the input no matter what it is, and it creates a subtraction problem. The first term takes the input and squares it, and then it multiplies it by 4. And then it always subtracts 3. When we're determining whether to call this an even, odd, or neither function, our input is the opposite of x. When we square a negative value, when we have a negative base raised to an even power, that's just a positive value. So this simplifies to 4x squared minus 3. And I compare this against the original function, and I see they're the same. I see that even though I plugged in a negative x, the output is the same as if you had plugged in a positive x. That, when you go to graph it, the x's are opposites of each other, but the y's, the output of the function, is equal. That will have symmetry with respect to the y-axis. That will be an even function. So I really don't have to continue any further. That if it's even, then it's not going to be odd, and it's not neither. That's my final answer. So I'm just going to move on, especially on a test or quiz. You want to answer things efficiently and then move on. So here, it must be part C. It's been cut off here. Let's determine whether this is even, odd, or neither. This function takes the input no matter what it is, and it creates 3 terms. The first term, it takes the input no matter what you gave it, and it simply squares it. And then it subtracts 2 times the input no matter what we give it. And then it always just adds the number 1. In determining whether it's an even, odd, or neither function, we want to give it the opposite of x. So we're going to have the opposite of x squared minus 2 times the opposite of x plus 1. So this expression simplifies. A negative x times a negative x is going to be a positive x squared plus 2x plus 1. That's not equal. The middle terms are opposite in sign, so this guy is not equal to the original, so it's not even. This is not an even function. If we go to take the opposite of this expression, we just change the sign of every term. X squared becomes negative x squared. Plus 2x becomes minus 2x. Plus 1 becomes minus 1. We now compare this expression against the original. And we see that the first terms are not the same. Now the second terms are, but the first and last terms are not equal to each other. This is not equal to the original. It is not odd. And since it's not even and it's not odd, it must be neither or Nigel. Alright, so that's my answer there. Alright, for these I'll do this on another video, but it's just flat out memorization. So talk to you later. Hope that helps.